Okay, so now the recording is started, and I think we're still ahead a couple minutes, but I don't think that's a big issue. I will start with the MuleSoft Runtime Release Cadence, which was actually announced just a couple weeks ago. And what is this about? So we have, before, in MuleSoft with version 4.4 and downwards, we had just one release channel. So there was always like one version with date patches, major, minor patches, but there was no fixed timeline and no differentiation between what is long-term support, what is not. And MuleSoft changed this with version 4.5 now. As we get two channels, it will be Edge and LTS, LTS for long-term support. And we come to the version support policy afterwards. So what is new? Also new is the new version scheme. Starting with 4.5, we will introduce, or we will get like pretty much real Semver version format. As we currently have like the major, minor, patch and date format, we now have major, minor, patch and the build with the channel attached. So you can see in the example, from the Edge channel, you will get versions in major, minor, patch, double, I don't know how this is actually called in English, but I think it's double colon. Or colon, or just a colon. Okay, thank you. Thank you, guys. So colon, and then you get the build version. And if you are on the Edge channel or you want to use an Edge version, you will append an E for Edge. And in the LTS version, you will have no channel identifier. So that's what we get from the new version scheme. And this is the new support policy. So what we had till now is the standard support for the current model was pretty much undefined. It was 12 months plus. We had like, whenever MuleSoft said it will not support this any longer, then it started, but you had no real information about this. Extended support was 12 months, end-of-life support was 12 months, only for RTF and hybrid at this point. CloudHub is not supporting end-of-life products. For the new Edge channel, you get 4 months of standard support and 4 months of extended support, and you will also get 12 months of end-of-life support. And why you will see in the next slide. And LTS will be 12 months in all support categories. So when you are relying on standard support, you pretty much need to update your application versions every 12 months. Or if you are okay with extended support, after the standard support, you have 2 years to actually update your APIs. And this is our new version timeline. So you can actually expect a new version at a specific month in a year. So what does this mean? So Edge is always 4 months. So you can see in October will be version 4.5 will be released on the Edge channel, and on the in February 2024 you will see the new version 4.6. Which is also on the Edge channel, but also on February, there will be the new LTS version will be released there. So, that's where you can stick with. It's like you can say, okay, I start with 4.6 in February, and I will need to, I can upgrade to 4.9 in February 2025. But you will still get 12 months more of extended support. And then you can see like all the, like every 4 months, you will get a new version of the MuleSoft Runtime And yeah, that's pretty much everything about the new MuleSoft Runtime Release Cadence. I think it's a cool feature that we actually know when we can expect a new version, and we can adjust the schedules to this. So that's for my part. I will hand over to Hendrik Siegeln now with the talk, with the main talk, MuleSoft deployments with large data volumes. Oh, I did a big S there, so so maybe really big data volumes. All right, so please take over if you want.
Thank you so much, Kai. I'm just hijacking your session. I hope my actually the voice is coming over. I'm having like issues the entire day. The bad thing is I can't ask you if you hear me, because if you don't hear me, actually you cannot respond. But I get a thumbs up from Birgit, but Birgit is sitting next door where I'm living here, so maybe she just hears me through the walls. Anyway, let's go for it. Yep, thank you again, Kai, for this nice introduction, and a big shout out to the round that we have here, and thanks because for confirmation everything is good. And we really need to have a chit chat about the fantastic food that I had enjoyed down there in Centon, and actually between Centon and Pretoria, I think was the office I was working. So some good old vibes coming up here. Brilliant. So let's talk about the large data volumes, and I actually spell it with a small s to not overwhelm people here. A journey into uncharted terrain. I'm doing integration works like for a bit over 20 years right now, and large data volumes always has been a thing. So I grew up like in a messaging company that were into high-speed messaging, and they had a very particular view on what is big data. And so let's talk about a bit about what large data volumes are really. When we talk about large data volumes, I'm talking about a combination of the payload size of an individual message and the frequency of how often that message arrives. So quite obviously, it could be a massive hundreds of gigabytes in size file that we receive once a day or once a week. But it could also be millions of messages, a megabyte size each. And what they have in common, basically, is that at a certain point in time, our system will be hit with a lot of data that it is asked to process. So the disclaimer, obviously, here is that it is in the eye of the beholder what those metrics really mean. So for some people, a 1 gigabyte file may be large. For other people, a 100 gigabyte file is just of medium size. The same for the cadence of how frequently these events come in. So whatever we say, take that into your own scenario, or I think it's a good time to use the chat again. So while I speak, you can put in the chat what you think would be large sizes when it comes to frequency of messages or the payload sizes. So today we really want to talk about a specific scenario. What I'm not going to talk about is I'm not going to talk about these messages that are small in size and come at an ultra high frequency. So we're not so much talking about the famous examples of stock ticks that you need to process like tens of thousands of messages per second, because personally, I believe that that's pretty much a done thing. Yeah. So there's not a lot we need to discuss. There's a lot of concepts. Kai said that we as the meetup group in Hamburg focus on architecture, and addressing that kind of volumes is pretty much the sort of thing nowadays, by being able to scale horizontally, use load balancing features of all sorts, employ hybrid deployments, and there's always tools like Kafka or other messaging systems will rescue if you need to buffer data that is coming in at too much speed, basically. And obviously we have the end boss enemy here, where there ultimately will probably not be a good answer, and that is processing large binary files where we need to access the content. So that is also something we will not discuss in detail here today, just to set straight. So if you're into that high frequency small messages thing, or if you're into chewing through 200, 400 megabyte size Excel spreadsheets, this session is probably not for you, but for everyone else, I hope this session is of some interest. So what do we know about the constraints that we actually live in when we need to process this data? There's only so much that we already know, and that is we know how much memory our engine has, and we can control this in our deployment models. So depending on which model you are, whether you are an on-premise hybrid model or RTF or in Cloud Hub, you pretty much know about the amount of memory, which ultimately determines how much data you can have in memory at any point in time. Then there's a tweaking, that is the data weave buffer size. I hope all of you guys are aware of what that means. It's basically when data weave is processing data, when the data is reaching a certain threshold, like it's getting bigger than the data weave buffer size, which you can configure both globally and on a productivity level, MuleSoft will start spooling data onto disk, and basically it will swap it to disk and swap it back into memory. And that will definitely lead to a serious performance degradation, because now you will have I/O that is based on the speed of the underlying hard disks. So we want to make sure whatever we do is nicely fitting into these data weave buffers. And there's not a lot, like I said, we can do about this, especially in the hosted environments. We cannot control the JVM parameters exactly as we like. And the data weave buffers, like the global settings, again, it's nothing we can control. It has been taken away from us with Cloud Hub 2.0 in the private spaces. We have been able to control this in Cloud Hub 1.0, as you may know. But now that feature pretty much went away from us. When we talk about performance degradation, the majority of us here in the meeting, we already have developed strategies for dealing with that. And performance typically in IT is measured in two KPIs, and that is throughput, which basically measures how many transactions become processed within a given period of time. And we measure the latency. And what we typically see when latency goes up, because, for example, we have data weave buffers overflowing and we have swapping in and out of data weave buffers, what we can do is we can increase the degree of concurrency in our MuleSoft application. So rather than having one flow being executed at any point in time, now we have two flows being executed, which will compensate for the increased latency and maintain our throughput. Right? So these concepts, I think we are all pretty familiar with, that once latency goes up, but we need to keep the throughput up, we just increase the level of concurrency. And that is something we can actually control in the MuleSoft engine. Again, to a certain degree, there are some hard limits. And as we all know, this only makes sense if our application that we have built is not CPU bound. Like if we're I/O bound, increasing concurrency typically helps to make better use of the available CPU cycles. Now, if we are CPU bound, we really don't want to increase concurrency anymore, because then eventually, again, we will have performance degradations. The other thing, however, we can control is transformations. So when we deal with big data and we have a very complex transformations, that has an impact on how long the data resides in memory, how CPU intense the data processing will be. And we need to address like all of this somehow. That is kind of like trying to set the stage about the constraints we are acting in, the amount of data that is thrown at us at any given point in time, the tools that we can use to address those, the constraints we cannot change, the limitations of the environment which we cannot change, and the stuff that we can control. So when we talk about processing big data, basically large data, I think I actually had a slide saying we're not talking about big data today. We talk about large data volumes. Big data is something completely different. So large volume data. MuleSoft basically has two prime principles, prime ways on how to deal with big data. large data volumes. And now I'm getting confused myself. And that is, we have batch jobs. Again, for the people knowing MuleSoft for a long time, it used to be a standalone product that you added on to MuleSoft. Nowadays, it's a part of your enterprise subscription. It very neatly integrates into the standard flow design that you have, batch processing, and we have the famous streaming, which is built in all the MuleSoft products, and it's like the standard way on how MuleSoft is meant to process data. But if we don't use it right, we break it all over the place, and then MuleSoft will stop streaming. Sometimes it's very obvious, sometimes it's not so obvious, and that will be my main focus during this talk, really, about streams. But let's tell the one from the other. So we both batch and streams obviously are designed to handle large sets of data. But we use them in different scenarios. So batch, I think, is very easy to explain. What happens in batch processing is you will read data from, like, large data volumes from a source, and the batching job will take a set of records that it somehow can identify. So it requires your data structure to be right. We will talk about that later. And then it will process the data record by record. So if you need to work on large data volumes, but for every record, you need to execute a certain sequence of components, batch processing may be the correct choice for you. So the idea here is that say you're working for a bank, and you have a huge payment file that you need to process, hundreds of millions of records in there. Then you can set up batch processing that will read the file in batches of 1,000 records, but then act on every individual record and make sure, like, the account numbers are right, the control sums match, the format is okay, and then you probably send it off to different systems in the bank. And you do that inside a batch step, record by record. This will also allow you to very granularly control transaction levels. So, for example, if you insert the data into a database and you need to do mass inserts, obviously you don't really want to commit your transaction after every record. So using batch processing, again, you can batch hundreds or 1,000 records before you close the database transaction and move on. So if you're in that scenario, batch processing is definitely the go-to place for you. So streaming, however, then is slightly different. But when we talk about streaming inside MuleSoft, we really talk about that we want to convert or process that stream of data, not on a record by record basis, but we really want to apply transformations, routing logic, probably to parts of the stream, reading and writing to that as efficiently as possible. Again, let's think about whatever you consider being a large data volume. I consider a large data volume being everything that I cannot fit in memory, like when I cannot fit the entire payload in memory at any point in time. Yeah, so I can only have bits and pieces of that in memory, and that is where streaming really comes along. It will read the stream step by step, put it into consumable pieces, and then forward it through the flow. And we will look later into how we can use that for our benefit. One more slide on talking about batches. This is like the summary, which I already said. So you need to do an operation on every individual record. You probably have to integrate with multiple systems as you do that. Remember my little payment example. You probably want to have individual error handling on records. Probably a bit future-looking statement here. If you have used DataWeave before and you did transformations on arrays, it's not that easy to have error handling on that element level inside your array. Batch processing will give you exactly that control. So you can run compensating transactions, error handling routines for that individual record. We talked a bit about the database scenario here. And what I forgot to mention is obviously within batch processing, you can run batches in parallel. So basically you can say, okay, do it in batches of 100 and run 10 of these batches in parallel. And as long as you're not CPU bound, you actually will see an improvement in your throughput for processing that amount of data. Once you're CPU bound, you will not see any benefit of that any longer, obviously. So that pretty much summarizes batches, and I hope you already get an idea on when you would use batches. In our real life examples, in our real life projects that we did, batches are not that commonly used. They're kind of edge cases. I would consider in at least integration matters daily life. Now your situation may be complicated. Talking about streams. This really should be the focus of my talk today. So when we are processing streams, really I'm thinking about dealing with very large payloads. Again, data that is too big to load into memory simultaneously, especially we have to consider that our Mule engine probably is processing multiple flows in parallel, and that we need to share the memory. So we want to really be as efficient with what we have as possible. What MuleSoft offers here is that for many of the data sources that we have, like files, databases, HTTP listeners, we can enable streaming. Some of these components, data sources, will offer streaming as a default option. Others, we must configure this. And this, like I said before, may not be that obvious in how we do this. I'll give you a couple of examples during the talk. So we really want to use streams versus batches if we want to work, if we want to work on just transforming the data, like we want to enrich the data, transform the data, like converting ISO country codes into country names. It says DE, but we want to have Germany in the file, and that is something you can do perfectly well by processing data as a stream. And you probably wouldn't need the batch because you don't need to do it on a record by record level. You really want to do it in the array itself. I just see there's a question of what I mean by something being CPU bound. So it's a term from the IT industry. When you process data, any data manipulation on a CPU will consume CPU cycles, and you know that from your local machine it says like 5% CPU usage, 10% CPU usage, and so on. And as long as you're not consuming the entirety of the available CPU, like your CPU usage is below 100%. And now we can argue that some engineers will say if it's basically below 75% or 70%, but let's assume it is running at 100%, then the CPU is your limiting factor. Like you cannot, whatever you try to do, you cannot process more data on that single CPU because it is running at full speed. Nothing you can do about that. So increasing the amount of parallel work that MuleSoft should do, like increasing the concurrency level of flows, will not help you in your throughput because you already are using all the CPU cycles available to the Mule runtime. Now, the opposite of that is that we are I/O bound. So we make a call, say, to a database, and that round trip takes 50 milliseconds. And while we are waiting on the response from the database for that transactions, or while the network card is offloading the data stream onto the database servers and is getting processed, the CPU is idling. It is not doing anything meaningful work. And if we would just run one flow in parallel, the CPU would be useless for 50 milliseconds, while in fact it could do some meaningful work. So in these scenarios where we have very low CPU usage, but we still don't have a high throughput, it is an indication that we are what is called I/O bound. Yeah, so we're either waiting on a network resource or we're waiting on a disk resource. So we wait on anything but a CPU cycle. So the golden rule here is bring up your Mule runtime dashboard, and check how much your CPU load is. And if you have not 100% CPU load, probably you can increase concurrency to get more throughput through your system. But if you're already running at a high percentage, increasing the concurrency will not help. Yeah, so that's the little explanation about that. Okay, we do streaming also for real-time process. I see very good questions actually coming up in the chat here. And Kai, you have to keep track. We need to answer those really. So we do real-time processing of the data in streams because it is like do it as rapidly as we can. So let's think about yeah, Bala, we want to talk about that. A good point. So let's talk about when we look at batches and when we look at streams and we want to use these efficiently, there are some commonalities between these two things. And I know I probably are talking about some generic places here, and you have been there and you've done that. And I just want to emphasize on that again, and that please stop using global variables. And what is a global variable anyway? So please stay away from patterns where you say, hi, I set a variable called original payload, and whatever data comes in, I store it in that variable and call it original payload so I can consume it later on. Yeah, or you initialize it in the beginning. Because that global variable will stay in memory all for the entire lifecycle of your instance of that flow. Even if you don't need it anymore, it will occupy memory. It will make life harder for the runtime. And typically, it is not required. So a strong indication that you have a flaw in your process design that will eventually cost you performance and stop you from processing large data volumes is that you copy inbound streams into something like original payload and you keep it there, or you store intermediate results from components, not directly in the payload message, but you put it in some intermediate result message. Yeah, so there are much better ways of doing that. And think about the Mule message as something that is constantly mutating while your flow is processing, and avoid having global variables. It's okay to have scope variables in your subflows because they're collected as soon as you leave the flow or inside your for each scopes. That's all fine because they're getting collected immediately. But avoid having them like on the top level flow, top flow level. Do lazy loading whenever required. I'm sure you're aware again of the read function in DataWeave, that you can read data from internal like class path resources, but also use that to query other HTTP sources. So only load the data really when you need that. And limitation in payload size is important if we are able to control that. And I will talk about that again in a second when we talk about files. Other patterns we can employ to better deal with large data is to actually use external storage. So rather than consuming all the data that hits us straight away, we could simply put it in some placeholder, in some bucket, and have it temporarily sitting, for example, in a database, in a queuing system, on the file system, but just not loading it into memory. Basically, what I'm saying here is accept the work, like the HTTP listener is accepting the work, but it's putting it straight on disk, streaming it on this, and gives an asynchronous response saying, okay, thank you for the work. We're going to do this asynchronously. Use tools like messaging and queuing tools to split the data and have individual pieces of work, items of work, sitting as individual messages, smaller messages on queuing systems. And I just came off a discussion discussing the benefits of a queuing system, and one of the big pros and cons really in MuleSoft is HTTP is like the predominant protocol we use to invoke other APIs. And it is a synchronous protocol, and we all love it because we really, really well understand HTTP in general. Now, from a computing resource perspective, HTTP is a really bad protocol, like because you as the client, you request a compute resource in real time from the server, and you basically say, okay, now do something for me right now, and I cannot wait, and do it as rapidly as you can. And if there are thousands and thousands of clients coming along, messages coming along, that can easily overwhelm my server. I mean, that's the whole idea of a denial of service attack. In the end, we overwhelm the server. So we are not really nice citizens in our application landscape if we purely rely on like these synchronous HTTP calls. And that is where messaging comes into place, where we, if that is possible in your data processing, that you take the data and you put it into messages, and then you have another API that consumes of these queues, because then it can consume the messages at the speed that your API and your backend system is capable of consuming the data. So instead of you forcing a system to please immediately respond to your request, when you subscribe to data in a queue, you can process the data at the speed that is comfortable for your API and your backend system, and you will not cause downstream problems with that SAP system you continuously overload, because you just try to get real-time responses from that. You probably figure I have a messaging background. I'm all for messaging. I think it's the better protocol. My view. We can have a good discussion about this after my presentation. All right. When we talk about error handling and recovery, there is I've seen so many things about like retrying. It is so obvious and so often done wrong. Only retry transient errors, transient failures. So what is a transient failure? A transient failure means I cannot connect to an external system because of a network outage. So the if you have been sporting RTF, Runtime Fabrics installations for a couple of years, you probably had the famous HTTP 205, 502 bad gateway errors in your installation. So that is a good example of a transient error. So issuing the HTTP call again in RTF may actually resolve that error, and then the second call is successful. However, if your data is the reason for the error, like you try to insert a record into a database and that violates a unique constraint, trying it again will not resolve the unique constraint violation, obviously. So don't retry that. Be very specific about the errors you want to retry. In most of the cases, it's better to report back that the transaction failed and ask the client to take a decision rather than us trying to save the planet, save the day. By doing all kind of fancy auto retry mechanisms and error handling. So again, when we talk about really big data files, so let's talk about that 100 gigabyte catalog file that has material. Like let's assume we're a big automotive shop. Like all the spare parts we sell are in one big massive XML catalog file, and we need to process that 100 gigabyte XML file. The worst thing that can happen is we shoot through 90% of that, and then the engine dies, and we need to redo it all again. So in these scenarios, you can apply a pattern where you write a watermark to a persistent storage, and you just remember how many bytes of the file you have read, so that when you recover from an outage, you can resume operation at that offset in the file. Yeah, the tools are available. It is possible doing this via Mule. If you're dealing with very big data, like files, watermarks are the thing. If you do this with data sets, it's sitting inside the database. It could be sequence numbers. It could be timestamps that you have been processing. You probably already have used high watermarks when you implemented file pollings in MuleSoft and these kind of things. So you are aware of the concept, but you can apply it to so many more scenarios. And eventually here I say, actually, in error handling, log always, but be very precise in what you log. So I'm a big fan of that you log the unique identifier of the transaction, and you only log the error and probably accompanying data in case of an error. But don't log milestones at a large scale. Don't log payloads. You may leak sensitive information if you do that anyway. And it costs a lot of CPU cycles to serialize the data we have in memory and just spooling it into a log file that most of the time we will never look at. Yeah, so be very conservative in your logging, actually. Make it very structured, have enough logging in there that you understand the course of the flow, but do not flood your log files. When we talk large data volumes, always remember the log files in CloudHub are rolled over at 100 megabyte in size. And when we process gigabytes of data within minutes, log files rotate so fast that we will not be able to understand what happened 5 minutes ago if we do too much logging. So these are the commonalities. This is what we share between when we do this in batches or when we actually do this in streams. All right. So streaming, again, so when we do streaming in MuleSoft, data is read in chunks. Again, we are all IT people here. We understand, we believe we understand what streaming really means. And if you've done Golang coding, Java coding, or any other good programming language, you exactly understand how buffered readers and writers work, how to stream data through a JVM, through the computer's memory, without the need to load the entire file before processing it, for example. MuleSoft always refers to 2 types of streams that it supports, but when they talk about streams here, it's something slightly different than what we in IT as programmers refer to as a stream. MuleSoft basically says, okay, when we read data from a socket or from a file, technically that's a data stream that we get, and we can take a decision if we want to have this data stream being repeatable, which streams in nature are not, or if you want to have this being non-repeatable. So if it's repeatable, MuleSoft will create a copy of the data, store it in memory or on file. It is your choice. You can say, okay, so it's file-based repeatable stream or it's a memory-based repeatable stream. And then when you access the stream, it will always reset to position 0 and start reading the stream from beginning to the end. And it's only when the flow terminates that stream eventually is closed and a memory or disk storage is tidied up. Now, talking about repeatable file-based streams, I mean, in memory, we all agree that there's only so much memory we can spend on having a copy in memory for that stream. Now disk storage is obviously cheaper, and there may be more disk storage available than heap. But if you're in a hosted environment, like if you run on CloudHub, remember that there is not unlimited local storage for your runtime. Yeah, the documentation is unclear to the degree of how much disk space you get when you spin up a Mule runtime in CloudHub. Rumors are the available disk space varies between 1 and 8 gigabyte. Take it with a grain of salt. This is just what I read up. This is what I heard. Yeah, it's word of mouth. But eventually that means we cannot have a repeatable file-based 100 gigabyte stream because it simply will not fit on disk, and it will eventually crash our node when we deploy it. So none of these 2 options are really an option when we really have to deal with large data volumes. So instead, the recommendation is to use the non-repeatable stream and treat all the data you read as if it would be non-repeatable. Now, that may scare many of us because it really means I can read it once and then it's gone. But keeping that in mind will make us better developers. So we will not carelessly consume the stream and not apply valuable work to it. But we will take that precious stream and deal with it with care and only do what it really is that we need to do. And that will make your application so much faster and more efficient if you keep that in mind. So for small messages, I don't care. Like everything that is below a megabyte, I don't care what kind of repeatable stream you do. But once it's getting larger, think about using non-repeatable streams to really beef up performance. So think about that non-repeatable stream. So once the stream breaks, the entire payload is lost. That means we must make sure that we process the stream as a stream from start to finish. And we must not do anything that breaks our stream. And actually, I think I'm running off the wrong presentation here. I just figured that because I worked on these screenshots before the presentation. Anyway, so let me save that. So it really starts with starting from your source. For example, in your HTTP listener or your file listener, make sure that you configure these for streaming. And I hope you can read it in the top right corner, like the output MIME type from your HTTP listener, for example. Isn't there something like a pen typically you can use? Yeah, here. Make sure your XML or your IDE, it shows streaming equals true inside the MIME type. If you don't do that, MuleSoft will make a best guess on whether it will make the data that is arriving over the HTTP listener as a stream or not. And it will do the same for sending the response. So if you have that multi-layered architecture of Experience API, Process API, System API, and you misconfigure your HTTP listeners, it may well be that somewhere through your API layers, you break the streaming mechanism. And that one of your APIs will suffer from that. So make sure you set that parameter, streaming equals true, on the output MIME type. Yeah. Some connectors allow very explicitly to set the streaming mode. Yeah, like the database. The database connector actually is a great connector because at least I think it's a great connector because you can set the size of the result sets and how it would be streamed, and then the size of the pages, and you can really fine tune how you want to read data from a database using a database connector. Also, the file connector has similar features. Again, for the file connector, you need to set the streaming equals true, but the default behavior for yes, the answer is streaming equals true for HTTP for all layers. Do it for all layers. Yeah, otherwise one of your APIs will break. So the file connector has a very nice streaming mode from the very beginning. Like when you act like on a new file, yeah, on new, what is it called, on new file or file change or something, and you access the output structure of that, and you start accessing the payload, this is actually when you start consuming the stream. In a proper setup, that source alone will not start consuming the file. So it will just trigger the flow. And it's only when you start accessing the stream that it will read from the stream. And we can talk about like common errors that people make when they use the file reader and how that breaks streaming when doing so. And also, what you can do is, and what you should do is, for example, this is the example, if you expect XML, it also works for JSON. It doesn't work for all. You can set the collection path here, which will result in that your listener, your data source, will parse the incoming data based on the MIME type that you set in the beginning, but it will try to read the elements, like in this XML example, for a complete order item before handing over that part of the stream to the next component, so that the next component can be assured that what it gets always is a full order item. Yeah, so I think it's a well-hidden feature in the engine, and it's poorly documented and not easy accessible. And I will show you in the IDE actually how to do this. But these are really powerful settings if you deal with structured data like JSON, CSVs, XML data. It obviously doesn't work so well with like binary data, yeah, because there's just doesn't work. All right. Now we just have talked about the source, and the sinks, by the way, work exactly the same way. Like when you do a write a file, that in nature is a stream. So as long as you feed a stream into the write file activity or into the HTTP response or request, it will be a stream when it's sent out. Yeah, unless you do stupid things with the stream. Yeah. So talking about stupid things, so what breaks the stream? Everything that requires random access to the stream will break the stream. So if you want to group things, group by some identifier, that requires DataWeave to consume the entire stream, because otherwise your groups would be incomplete, obviously. If you need to order, sort, concatenate objects or arrays, all these operations will break your stream. Just put yourself in the shoes of the DataWeave engine, and when you put in something like ordering or sorting, grouping, would you have to read the entire data before you can find that eventual grouping? And if the answer is yes, I need to understand the full data set, this will break your stream. You will completely consume the stream and you will lose all the benefits of streaming. Some things are not so obvious sometimes, like operations like concatenating arrays, yeah, can force the entire payload into memory. I hope there are enough Java coders here in the room. Just remember the difference between string plus string versus string buffer append. Yeah, that subtle difference in there, but the one is so much more memory efficient than the other. Yeah, so same here. Don't do concatenations on your data streams. That doesn't mean you're not allowed to have local variables like in a do scope in DataWeave, for example, because that will not break the stream. Yeah, so you can concatenate those parts of the stream, but do not do concatenation on the entirety of the stream. Do not access elements by index or name. I think, again, that's obvious. If you say, give me the fifth but last entry of an array, we obviously need to understand the size of the array. If we say randomly, give me the 100th element in the array, obviously the stream has to fast forward to the 100th element, and we will lose everything in between. Yeah, so just don't do that. It will break your stream and result in yes, very good comment here. Examples for non-breaking operations. The famous map, we all use that. Yeah? Filter, plug, reduce. I mean, map reduce. Go figure. Yeah, it's a non-breaking streaming mechanism. That's why it's so famous, that pattern. And I'm not sure if you're aware of the DataWeave directive that is called deferred equals true. I have no idea if you heard about that, if you're using that. But what it does is, like, you put it here, you put it on the on your output line where you say deferred equals true. It's not available for all MIME types. It is available for JSON, XML, and some others. Yeah, but for example, it's not available if your output is application/Java. How would you stream a Java object? I know technically it's possible. I understand this, but like for the sake of my example here. So read up, give it a try. Actually, the auto completion in Anypoint Studio will show you whether deferred is a available directive on that MIME type or not. So, but what does it do? It actually defers the evaluation of that DataWeave script to the point in time when you actually access the result of the DataWeave script. Yeah, so if you need to prepare a data structure and you think you need to prepare it, but you don't really know if you need that later, use defer, because only when the data is accessed, that is actually when the script is executed and your streams will get consumed. And I like the discussions actually that's going on in the background here. So that is what defer really is for. And I like for the old guys in the room, like same like my age, you probably remember the defer function. Like I removed actually this from the real one. There used to be a defer function where you actually could have that same feature like on the attribute level inside an object. That has been deprecated. It's no longer available. Yeah, so please don't use that. Don't get me started on code builder, please here. So don't use the defer anymore. If you have that in your code, remove it. Move the deferred equals true into the header section, and you're good to go. Yeah. All right. That's the defer example, and I'm almost done with my presentation. I think I'm doing great in time, by the way, Kai. Yeah. So no reason to be. Oh, actually, final 2 slides already here. I will switch to the IDE in a second and give something, some more explanations here. So what did we not cover? And there are many more things. Like I could talk about large data volumes for hours. As you see, I'm really passionate about processing large data volumes and doing that also with MuleSoft. And if it wouldn't be for you guys sitting in Paris and Madrid and Pretoria, it would be so cool to sit down on a bar right now and have a nice beer and talk about that. So we haven't talked about pagination, for example. Pagination is another concept of how we can deal with large data sets where we query a resource and we get data in pages. Like when we access a database, like the database connector has built-in pagination. But if you're dealing with tools like, if you have OData interfaces, I see enough guys here that have done SAP OData integration. So pagination actually is a thing, yeah, and it's good to do it and continuously consume the stream that is coming in through the OData connectors that MuleSoft is providing. Think about doing pre and post processing of files. It is not absolutely not required for you to, when you get a file, that you just try to swallow it in one go. There's running a pre-processing script on a server that will split the file is not cheating. Yeah, that is a smart move. Let's offload some work to some other computers and split the work, and we can work on this more efficiently, and then have some post-processing to combine the files again, or do whatever you want. There's absolutely no need to do it all inside the new runtime. If you think there's a more clever way of doing that, do it. Like offload the task to other servers. Let the database do the heavy lifting. You know, have all your data in the database and say, hey, you know what? I know you have a gazillion amount of records, but I need row gazillion minus 10 until to gazillion. And let that heavy lifting be done by the database. Absolutely no reason to do it yourself. If response times are important, like clients hand you big data, like they give you the 100 gigabyte file over an HTTP post. I don't know why they would do this, but they do this. But they don't really want to wait for the processing. Think about async scopes. Again, think about you give up control in the main flow. You have to handle async responses. You have to build APIs that give a status on the state of processing of the data that you're handling asynchronously. So there's a lot of stuff you need to consider. That could be an entire talk during our next meetup. Again, architectural, very challenging async scopes are really nice. Webhooks have been invented here. Yeah, so if you want to read up on that, very nice stuff. We really haven't covered connection pools. Like it doesn't help if you do like the most efficient data weave scripting and you use batch processing and you run 100 threads in parallel because you have that beefy machine. But if your database connection pool only allows 5 concurrent connections, that's probably not good. So we have to think about connection pools. Good news is some adapters have connection pools. Bad news is some have not. And big fights with product management for the ones that don't have connection pooling, but at least where we cannot control the connection pools. Siegeln adapter being one of those. So connection pools, we haven't addressed this, and we haven't talked about data compression. So there are ways that we can pre-compress the data, like removing spaces, that makes it all more efficient. Like use a pre-processing script, for example, to get rid of line breaks and spaces in a formatted XML file or JSON file can reduce the amount of data you have to process by 30% without turning that into a binary file. Think about that. And I hope you know that in DataWeave, when you produce these large data files, in DataWeave, you can actually turn off the auto indenting for JSON and for XML. Just turn it off. It saves so many characters. Like I said, it reduces the payload by a significant amount of bytes when you process that. This was my final slide, but I promised that I actually will show you 2 or 3 things in the IDE, so where you find things. And if you still have time and stay with me, I will switch and I will share my little IDE, which has a lot of non-working code. But I want to share a few things with you here. I hope you can see that. Sometimes, again, it's like resolution is playing tricks on me. I just assume you can see all of this. No, I'm not seeing the chat anymore, just if you wonder. So remember about what I said about the HTTP listener here and the application XML, collection path, order, streaming through. Yeah, so you can, obviously, you can put it here. But what you really should do is go to the listener. And here under the advanced, under the MIME type, you can set these parameters. Yeah, so this is the proper configuration to stream a XML file, a file you receive, and collect it on the order items elements, and then stream it onwards to some other destination. Yeah, so use these MIME types. For that file listener that I was talking about, it's the same thing. Actually, I probably didn't edit here, but you can say file listener. And if you want to cheat like me, just go here and do code completion and search for the streaming modes. And somewhere in here, it will be there. So you can do things basically here in the XML straight away. Like the output of this one, here's the output, here's my output. Like what this payload by default will be streamed. So as soon as you access the payload, you will actually start consuming the stream. So here, when you turn that into a non-repeatable stream, but treat it with care and love and hug it, and then you can actually have end-to-end streaming in the file listener. What I said about that data weave here, like Java, do autocomplete here. Java only allows setting these 2 directives, but if I change that to JSON, you see you can make it deferred, and you can turn off indentation. And I really like if it's a really big file that is read by a machine, make it deferred and don't do the indent. Yeah, just I know you can't see a space, but a space is a byte on the wire, and you don't really want to. You don't want to save spaces just for indentation reasons. Yeah. So do these things. And this is the little example for the batches. So again, I have my little file source here, and now on the batch job itself, this is where you set how many records you wanna process. And I just put this in here for demonstrating that you can have a streaming inbound source and still have batching. Yeah, so you can combine these 2 things. It is just that inside the batch step, you will not have the streaming from that inbound stream. Yeah, so the stream is parsed, 100 elements are read, put into the batch step, and you can work on that in parallel. Yeah, so these are ways on how you combine that. Fun thing, another example on how to work with streams is like in this example, we use scatter-gather to read 2 very large files and then combine them into one single file. And that is all streaming, and this little process can merge files of any size. Yeah, there's no limitation how large these files are. It's just like a demonstration. I know there are other ways on how to concatenate files, but just think about that a simple redirect and append file, like on a terminal level, on a DOS level, doesn't work if you have structured data like JSON or XML. Yeah, you cannot simply just append to XML files because it's invalid XML in the end. By doing it this way, you will concatenate the content and produce a correct XML file at the end, or JSON file at the end. Yeah, that is just an example. That's it. Virtually no one ran away during my presentation, which I really highly appreciate. And I'm ready to hand over back to you, Kai.
Awesome. Really, I hope you can hear me. Yes, I think so. Awesome talk, Hendrik. Really cool. There was a really good discussion in the chat, as you mentioned. Some questions were answered, some were not answered, but I think we can do this in the short Q&A session we will just have after I just talked about the next slide I have prepared, or actually Birgit has prepared. I want to give you a heads up. Our next virtual MuleSoft meetup is coming up in November on the 16th. Same time, pretty much same location. So we will see us if you want again here in the Teams. And we have a really exciting guest speaker, which is Andreas Oberrauter from MuleSoft. And he will talk about monitoring and analytics. So if this is a topic interesting for you, then feel free to join and RSVP as soon as the meetup is online. But if you have subscribed to this meetup or the location, Hamburg, then you will get a notification whenever we host a meetup. So just make sure to do this if you are interested. And yes, so that's from this part. And I just need to take a look where I can share my other slide. Just need a second here. Where is it? Documents. So starting my present. Also, assets. So starting PowerPoint Live. Oh, we're starting at the front. Okay, I'll just skip all the parts, and we are heading directly to the Q&A session. Really big thank you, Hendrik, for your talk. I think it was really valuable for some, or maybe hopefully a lot of the people in here. And one thing, I think we can start with one of the last questions. It was about error handling while streaming. That site that it is a scary dark corner. So maybe you can bring some light into this scary dark corner.
Yeah. So error handling while streaming is, I mean, obviously it is possible. Like you can still throw exceptions and these kind of things. It is just very important that while you do that, you make sure that you don't destroy the stream. The majority of error handlings will kill your stream, basically. Simply because sometimes it overloads, like it puts the error message in the payload. So some components behave really nice and just throw an exception that is available as an error. But so to be a good pattern typically would be that when you have an error, you would also write that to the log file, including the data that caused the error. Now, if we don't have that data at hand because we did it during the streaming and we don't have a copy of that, if we try to recover it, that will most certainly kill the stream. So you have to be very picky on which variable you choose to then have that piece of data in your error message. It is doable, and you need to test it out in the end if you broke the stream or not. And mainly you can only measure if you broke the stream if you monitor your system closely enough after the change and you check it for memory consumptions. Marco, I know you did a lot of debugging on this one. If you have an insight on that, it would be great to put that in the chat, or maybe later on, and we put it as additional information on the slides. But I know you did a lot of investigation on that one. By the way, thanks, Marco. I wouldn't have done the presentation without your input here. So that's what I can say about the error handling. Yeah. So in general, obviously you need to do it. Just be careful on what you log. Yeah, don't log payload. Yeah, just obviously.
So coming back to the logging, there was actually a good question from Wikus, which was what should be logged at the bare minimum? And I've partially responded to this question already. And just to give you a heads up, I said in best case, nothing. So this would probably be the fastest solution, but this is mostly not sufficient for every environment. But especially for production, you should probably just log what is necessary. And in most cases, you log to when you have an error or an unexpected event. And if you need some debugging, I said that you should use the log categories and enable logging as necessary using the runtime manager. What is your thoughts about this?
Yeah, I actually I'm also in the department of only log errors. Like that would be my default. Don't log successes. But my experience is that in many cases, when things go wrong, all people turn around and point at the integration tool, at the team that is running the integration, because we are always the bad guys. Yeah, it's always, oh, MuleSoft fails, MuleSoft is bad. But in fact, SAP is down, and that happens more often than SAP people would admit. So they always shout at us and look at us. And so what I tend to do nowadays is that I also have a positive logging where I log the unique identifier of the record that I'm processing, so that at least I can prove I received that request, or if it's not in the log, I didn't receive the request, and I processed it, and here's my success message. And I use just the unique key because that can be used to identify the record in the source system. So I don't put the entire data there, and that is a habit I developed because too many fingers were pointing at me at some point during my career, and like a line of self-defense. Apart from that, I'm more into the don't log anything. And I think we had a related question here, and that was, should we externalize log files? And I just add on that, if that's okay, Kai,
Sure.
because I'm yes, absolutely, I'm all for it. Please do it, guy. And so use tools like Elasticsearch, Splunk, Datadog, or even our Engine solution that we offer at Integration Matters. Yes, I'm an absolute fan of doing that, and I'm primarily for two reasons, and that is we can have more than 100 megabyte of log files even in the normal subscriptions of MuleSoft. Plus, we will have log aggregation. So I'm really getting annoyed when I need to trace a log across multiple APIs, and I have to. I'm in this click mania in Runtime Manager where I need to switch between the applications and find the log file and go to the correct log file. That is just getting on my nerves. So yes, if you can externalize the logs, always do it. If you can afford it, do it. Go for it. Yeah, we are always the bad guys. That is so true. Yeah.
Yeah. Okay, so I would say we can add a check mark on the logging thing. But we had also a question for streaming, also from Dev. It's streaming equals true for HTTP for all the layers. So the question is experience process system API, or would you say streaming only for some of these APIs?
No, I would always try to apply it as much as we can. Like if you follow the real vanilla architecture guidelines by MuleSoft, you would have these 3 layers, and just having 3 layers, it actually can mean you have many more layers in between here also. And you really want to have end-to-end streaming. That is my take on that. There's very rare a case where you would intentionally break the stream. halfway through. Typically, you really want to do this end to end. A reason for breaking the stream could be we had that with a financial institution where all the data we accepted, we first had to put it into quarantine and have a virus scan running over the data that we received. And like here, obviously, we would break the stream, but then when we pick up the data again, we would have streaming all the way through.
Cool, awesome. And I think we have a last question here from also from Bikus. Oh, okay. Would a try block with an on continue prevent stream destruction?
Actually, I don't think so, as long as you don't do stupid things in your error handler. Yeah. It may be a. It may also be dependent on the component you are using. I'm not 100% sure, actually. I'm sorry. You have to be in the next meetup here, and I will give you an answer in the next meetup. So we have one guaranteed booking for the next meetup.
Awesome. Tough question. Good answer, I would say. Awesome. Would like to see you again, because. Okay, and I think we pretty much covered. Oh no, there was some questions before. Let me just see what we had here. So from the part of scaling, Bala asked, vertical scaling will not be efficient to process larger payloads. Is this correct?
Actually, I really would appreciate having like an open mic here for everyone and share your thoughts on.
Everyone can actually talk if they want. Just don't talk all together at the same time, but you are free to open your mic if you want to.
So for the time being, while the guys decide to unmute themselves and join the conversation, when I think the pendulum swings all the time between having everything on one big box and having many smaller machines, and currently we are again somewhere in the middle of the swing. We have been on extremes of doing horizontal scaling with the advent of microservices and cloud solutions and all these kind of things. And now the pendulum, I think, slightly comes back into having more beefy machines again. So we make our microservices, we put them on bigger machines today. And yes, it's sometimes that can be your only option. In the days that I grew up, scaling vertically was the most expensive option you could have. Like doubling the amount of CPU cycles on a machine could be 4 times more expensive than just adding another box to your server park. So if scaling vertically is an option for you, it has many benefits. That is my point, really. Like if you run the hardware yourself, the amount of hardware you manage is still the same. If you operate the services, you still only have the same amount of instances you need to manage. So vertically scaling makes things much easier in operation. But it's probably the more costly option in the end. But that's my take, and that's just my opinion. And if you want to add to my opinion, or if you're against it, just speak up. We can only learn from discussions and opinions.
Awesome. So I think that's we have covered everything so far. Correct me if I'm wrong. If you have any other questions, just ask them directly here now, or put them in a chat now. Otherwise, I think we are pretty much through everything here for today. So if you have something.
I think we had the question about the slides. The slides will be shared. I'm not sure if we shared the slides, but the recording will definitely be available. I don't know if you have a way of sharing the slides via the meetup.
We did this the last time too, so you can check out the last Hamburg meetup. We shared the slides and the video on the meetup page, and this is what we try to do for this meetup too. So it will be available on the same page where you registered for this meetup. So you can find everything there, and yeah, that's where we share our experience here.
All right.
All right. So if there's no more question, then I would say another thank you, Hendrik, for joining us today and having this awesome talk. Thanks to everyone to attend here, and I have to say I think we exceeded our last participant count. So we had quite a stable amount of people in here, and I liked the really good conversations. And I hope I can see you next time too.
Thanks. Bye-bye. Thank you. Very nice of you, Bera. Thank you so much.
Awesome. Bye-bye. Okay, see you guys. Have a great day. Awesome. It's nice feedback.